Okay, so let's go back and review kind of what we did on Friday. Okay, and express using interval notation. At most 10. Okay, so what I like to do is draw it as a graph at first. So at most 10, 10's right here, would be a closed circle, wouldn't it? Going this way, right? It can be 10, it just can't be greater than 10, right? It can equal 10. So your interval notation would be negative infinity to 10 included. Included means brackets, right? Between negative 2 and 5, including 5. A lot of times they'll say instead of including 5, they'll say negative 2 and less than or equal to 5. That means the same thing as included, okay? So then when I graph these two on the number line, open circle and 5 would be here, closed circle included, okay? And then that would be negative 2 parentheses 5 brackets. Correct? More than 3 or less than 0. More than 3, okay? More than 3. 0 here, 3 here. More than 3. It's going to go like that. And then less than 0 would be here. So remember, negative infinities down here, positive infinities here. All right? So work left to right. Negative infinity to 0, parentheses, correct? And then you got to connect it with an or because they're going in opposite directions. And then 3 parentheses to positive infinity. At least 10. So there's 0, 10's say here, all relative. At least 10. So that would be closed circle and everything going that way, wouldn't it? Correct? To play on a soccer team, 16 and under, you have to be at least 16 years old, correct? Right? So you can be 16, you can be 7, you can be putting it the wrong way. I don't know if you could play on a 16U team and be 17 years old, right? I think you'd have to be less than 16, right? So at least 10. So to drive, you have to be at least 16 years old. Correct? So you can be 16, 17, 18. If you're 15, then you're doing what? You're driving on a restricted license. Agreed? Does that make more sense? So at least 16 years old to drive. Okay? So it'd be 10 included to print to infinity. And then this one here is a bounded solution, negative 4, 0, open circle, connected. So then that would be negative 4 to 0. Both of them are parentheses in interval notation. Okay, so today we've already solved up to now equations. Today we're going to do inequalities. Okay, so what will be different about answers to the inequalities compared to the equations? They are, the solutions at least, they are intervals. Intervals instead of points like when we solved equation. Instead of points. They'll end up being intervals instead of points. Now, for some reason, this was cut out of your notes. You're going to have to write this down. You can do it down in this area here if you want. But you're going to have two types of inequalities. You're going to have an and you're going to have an or. Okay? The first one is when the inequality is less than or less than or equal to so it's either going to be like this is an and problem. It's either going to be like this, less than or less than or equal to. So it looks like this. Absolute value of x is less than or equal to some constant. That could also just not have the equal sign, okay? Could be just less than. So your two inequalities that you're going to write are going to be x is greater than or equal to negative c and x is less than or equal to positive c. And with ands, you can put them together. And get this. And both conditions, both of these must be true. That's an and. We're going to have less than, we're going to have less than or equal to will be ands. Okay? Or is greater than or greater than or equal to. That is an or problem. You'll set them up the same way. So you'll have, you could either have greater than or equal to. So I'm going to write them with greater than or equal to. So your first one's going to be x is less than or equal to x is less than or equal to negative c, or x is greater than or equal to positive c. And you can't put these two together. They're going to go in opposite directions. And only one condition needs to be satisfied. It can be both, but not required. Okay, first example, okay? I like to write with bigger, so I'm gonna do it on a separate sheet of paper. Okay, so this first one, we have the absolute value of 4x plus 5 is greater than 13. So this is an or problem, isn't it? Because it's greater than. Or. So, Your first inequality will be 4x plus 5 is less than negative 13. And your second one, is 4x plus 5 is greater than positive 13. Subtract 5. Divide by 4. I get negative 9/2 because I got negative 18 divided by 4. So x is less than negative 4.5. I wrote it as a decimal, okay? This one here, subtract 5. So that would give me 8. Divide by 4, I get x is greater than 2. So there is our solution. Subtract 5, divide by 4, correct? 8 divided by 4 is 2. All right, let's graph it. Okay, x is less than negative 4.5, so it's going to be a open circle going that direction. Agreed? Everybody see where I got that? And then this one here is going to be an open circle going this way. Ors, not always, but most of the time are going to look like this. They're going to go opposite directions. Not all the time, but most of the time. Okay? Okay, watch this. Watch this real quick before we finish this thing. Let's pick a number which is not in the interval. Plug in 0. What's 4 times 0? Plus 5? What's the absolute value of 5? 5, correct? Is 5 greater than 13? No, that's why it doesn't work. Correct? Let's try another number, negative 3. It shouldn't work either, should it? Because it's not. So 4 times negative 3 is negative 12, plus 5 is negative 7. The absolute value of negative 7 is 7. Is 7 greater than 13? No. I could pick another number over here, say negative 6. 4 times, which should work, correct? Because it's in this interval, agreed? 4 times negative 6 is negative 24. Plus 5 would be negative 19. The absolute value of negative 19 is positive 19. Is it greater than 13? Pick a number greater than 2. Say 5. 4 times 5 is 20. 20 plus 5 is 25. Absolute value 25 is 5. Is it greater than 13? Correct? See how that works? Or no? I can do it in my head. Okay? So now let's write our interval notation. Negative infinity to negative 4.5 or 2 to positive infinity. And there it is. Remember, negative infinities here, positive infinities here. Okay, example 2. I have 2 times absolute value of 1/2 x minus 10. Absolute value is less than or equal to 8. Is that what you guys have on your paper? Okay. Now, first place, we've got to isolate the absolute value, right? So we're going to divide both sides by what? 2. So we have to do that first. Okay, now is this an and or an or? This is an and. Why?
Because 8 is greater than.
It's less than, isn't it? Less than or equal to, agreed? So let's write our 2 inequalities. 1/2 x minus 10 is greater than or equal to negative 4. And 1/2 x minus 10 is less than or equal to positive 4. Okay, everybody stop. You're going to do them both the same way, aren't you? Everybody look here, just real quick. This thing here on the right side is going to be exactly like that, except without the absolute values, correct? Those two will be the same. That's the positive side. So there's the first inequality and there's the second inequality. The first inequality is going to be copied, correct? Except the inequality is reversed and the sign is reversed. Does that make sense? Correct or no? So the first inequality is going to be that with that reversed and the opposite sign. The second one is going to be exactly like that except with the absolute values. It's going to be that way every time. Does that make sense? Or no? Okay, add 10. Multiply both sides by 2. We got x is greater than or equal to 12. Add 10. Multiply both sides by 2. I get 28. And remember, we can write this like this. Correct? These two are the same thing, aren't they? Correct? Graph it. And ands normally look like that, bottom part of a train. Interval notation, 12 brackets to 28 brackets, correct? Okay, example 3. Do what? Okay, the one thing I'm going to say in here is you should be doing it before I do it. Okay, I think it's great you want to know how to do it, but you should be doing it ahead of me, especially where you're solving these equations, correct? Or you're not engaged. If you're listening to music right now, I assume if you got AirPods in that you're listening to music. Yep.
So on that last one, it was 1/2 x is greater than or equal to 14. You got 28 out of that. Wouldn't that be 7?
That's 1/2. You got to multiply by the reciprocal, right? When you divide, that's a great question. Good job. I would divide by 1/2, but when you actually divide by a fraction, you actually multiply by the reciprocal, correct? Right? You multiply both sides by 2. Very good. Great question. Love it. Those are really good questions. Okay, ready for example 3? Absolute value, or distance from 0, is negative 2x plus 3. Plus 3 is less than 8. Correct? I got to get rid of that bird right there, don't I? I got to isolate it. So I got to subtract 3 from both sides. Agreed? I got to isolate the absolute value first. Okay? So is this an and or an or? This is an and problem, right? Because it's less than. Agreed? Okay? So we're going to have negative 2x plus 3 is greater than negative 5. There's your first one. And negative 2x plus 3 is less than positive 5. The one on the right, the second equation, is always copied down except with the absolute value. The first one is copied down except you reverse the inequality and you negate the constant. Does that make sense? Subtract 3. Okay, here it gets tricky. How many remember from Algebra 1 when you divide both sides of an inequality by negative, you reverse the inequality? So when I divide by negative 2, I have to reverse that inequality. So now it's less than 4. How many remember that, kind of? And then I'm going to subtract 3 Divide by negative 2, I'm going to have to reverse the inequality again. So when I go to graph this bird, do what? Negative 1, 4. Going to be here, open circle, here, open circle, connected, correct? Right? You could also write it like this. And your interval notation would be this. Parentheses because there's no equal signs. Does everybody have that? Feel like they can do it? Okay, I'm going to do a couple of quick examples in day 2, and then that'll be it for the day. Okay, so what do we have to do here first? We've got to divide by 2. So that gives me this. Now I want you to think about something, correct? This, no matter what I get for x, what am I always going to get out of it? And I said it earlier. What are you always going to get out of that absolute value? Either positive or what? 0, correct? Okay? Of course, we have this. And this is negative, isn't it? Now let's think about this. No matter what I get for that absolute value, whatever I get for x, what's always going to come out of it? Either a positive or 0, right? Well, won't it always be greater than that negative 16? Correct? Always. So this one here is all real numbers. This one here is the number line. Any number that you get for x will work on this one here. And interval notation would be this. This one here is all real numbers. Think about it. If I got negative 5, what's negative 5 plus 1? Negative 4, what's the absolute value of negative 5? 5? Is 5 always going to be greater than that? No matter what I get for x, and I plug it in, it's always going to be positive, which will be greater than negative 16, won't it? Okay? Now example 2. So this one here, whenever you have an absolute value greater than or equal to negative, it's always going to be all real numbers. This statement is always true. Solution is all real numbers. Right much? Do what now? Okay, so to solve this one here, what do we have to do first? Divide by 1/5, or actually multiply both sides by what? 5. So does everybody agree with me? I get this here. Correct? Now, what are we always going to get out of this side? Positive or what? 0. Agreed? And we have this, of course. And then what are we always going to get there? It's always going to be a what? No matter what we get for x and we plug in an absolute value, will it ever be less than negative? Will it? It's always going to. Will it ever be less than negative 25? That can never happen, can it? No matter what I get for x and I plug it in, I'm going to get a positive, aren't I? Correct? So can it ever be less than negative 25? No. So this one here is no solution. No solution. A positive number or 0 can't be smaller than a negative. So there is no solution. Okay, that's enough for today. Okay, there's two